So I want to go to a graduate school for biomedical engineering. So I'm going to graduate Rollins with a degree in biology and physics as my majors, and then hopefully minors in chemistry and mathematics. So how do those things that I'm doing in Rollins right now fit into my graduate school ambitions? So let's break down biomedical engineering grad school. So first off, biomedical. That feels very self-explanatory. Biology and chemistry are the basics of medicine. Learning about, I'll do a class on human physiology and human anatomy, vertebrate zoology. All of those things are going to allow me to form better connections between disparate subjects. So take, for example, human physiology. Of course, I'm going to learn about the different muscular systems and the digestive system, the vascular system of the human body, and then anatomy, bringing those all together. Vertebrate zoology, being able to bring those skills and understanding of the human body to other vertebrates as well, and then to the biomedical field. If I want to focus on, say, orthopedic biomechanics, then I would have to know very much about bones as well as how they move around. So physics would help as well in knowing the mechanics of that. And so obviously for the bio part of biomedical, biology is going to help a lot with that. And as well as chem, understanding how different chemicals move throughout the body and their different effects on the body. And how does differential equations fit into that as well? So the differential equations are just very useful for whenever you can measure the rate at which something moves, but not the actual amounts. That's really the core point of differential equations. They allow you to better understand the world around you, so you can see something moving and then extrapolate how its position is going to change. And so that has so many different uses. Something that I would like to focus on in graduate school is prosthetics, and maybe working on creating an actively powered prosthetic. Differential equations are going to be super important in controlling the movement of that prosthetic, of modeling how your brain sends signals to move your arm, or the medicines that are going to be needed to allow that prosthetic or any other biomedical device to sit in your body, understanding how that medicine is going to interact with different parts of your system. So that brings me to the second part, engineering. So in engineering, physics obviously is going to be very useful for that, because engineering is basically just applying physics to creating new technologies. Specifically with biomechanics, physics, one of the large parts is how do objects move throughout the universe, and that is mechanics, right? So being able to use that and my knowledge from biology to see how your body is going to interact with the force and then move. So physics is super important and useful for that as well. And then differential equations as well. Differential equations have a very easy analog to the real world in terms of movement. And so being able to understand that allows you to just get a better idea of how whatever engineering problem you're working on actually works in the real world. And it's really useful for having that greater understanding. Additionally, as part of my ordinary differential equations class, I had to write a paper and extend a model of a previous differential equation that has been previously published, and then give a presentation on that. So bringing my classmates who have that base understanding of differential equations, but bring them up to the level of understanding required by that paper in that presentation. And then writing a paper about how I extended that model, figuring out what problem needs to be addressed, and then figuring out how to address that, which is a very important part of graduate school of having a doctorate, is being able to publish those papers. And so overall, biology, physics, ordinary differential equations are all things that are going to be very important in my goal of being a biomedical engineering grad school student.